Alright guys, so our goal for this lesson is to be able to graph a quadratic function that's given in standard form. And we've got some sub-objectives that will help us do that listed below, and our essential question is, how does finding the axis of symmetry help you calculate the vertex? So be listening and thinking about that as we work through this lesson. Alright, so by the end of this lesson, I should be able to take a function in standard form and put it on a graph without the use of a calculator. Alright, so this is technically a review of Algebra 1, so I want you to pause the video and I want you to take this graph right here and see if you can identify these different characteristics or key features of the graph, and we will talk about them in just a minute. Keep in mind that all of them may not be on the same graph. So for instance, I can't have a minimum and a maximum when I'm talking about a quadratic. Alright, we talk a lot about your notes are for you. So with this slide, if you have a vocab word that you're not familiar with, I would write that down. But as far as the other ones, if I know what it is, then I don't necessarily need that in my notes. Alright, so the point where the graph crosses the y-axis, that one's pretty straightforward. It's the y-intercept. And note that we always write the y-intercept as an ordered pair. Alright, the vertical line that divides the graph into two congruent halves, that is the axis of symmetry. And it's a vertical line, so if it is a vertical line, that means it's only crossing the x-axis, so we always write it as x equals, because it is a line. So just like y equals 2x plus 3 is a line, x equals 4 is the vertical line that crosses at 4. So the vertical line that divides the graph into two congruent halves, the axis of symmetry, is always notated as x equals whatever that value is. The other thing to know about the axis of symmetry, in order to calculate that x equals, we're going to use this formula, the opposite of b over 2a, and that is something that you need to memorize. We will do a lot of work with it, so hopefully that won't be too hard. But x equals the opposite of b over 2a. Alright, the point or points where the graph crosses the x-axis, also known as the x-intercepts. Alright, they are known as x-intercepts. They're also known as roots, zeros, and solutions. So when you hear one of those four terms, you need to know exactly what we're talking about. And a quadratic is going to have either 0 solutions, 1 solution, or 2 solutions. And we'll talk more about that in our next module, but just be familiar with that. And we always notate it as x equals. And then if there's 2 solutions, we do the smaller number, comma, the larger number. Alright, the minimum or maximum is the vertex, and it's a point, so we name it as an ordered pair. If the graph opens up, so if it's a parabola that opens up, obviously I have a minimum. If the graph opens down, then I have a maximum point. The set of all inputs possible for the function is the domain, and for the sake of simplicity and time, we're going to stick with interval notation. If you were to write set notation, it wouldn't be wrong, but I just need you to know that we're going to mostly be dealing with interval notation. So the set of all outputs, y coordinates, possible for the function is going to be the range. The intervals over which the y values are increasing as the x values increase. And then the interval over which the y values are decreasing as the x values increase, those are known as positive and negative graphs. And then finally, the horizontal and vertical direction of the graph at each end, that's the end behavior. Now, I want to make one quick note. We are going to talk in this video about the end behavior, and we're going to speak in general terms, and then tomorrow in class, we're going to dive more into how to write the correct notation and interpret that. Alright, so we know from the first module that the parent graph of a quadratic is y equals x squared. That's my general formula, and it starts at 0, 0, and it opens up. It makes that parabola open up. So I do want to start with this table, because this table is going to make your life a whole lot easier if you can memorize this table and be able to work with this table. So when I think about y equals x squared, so my input is being squared. So let's just come up with some general values that we can plug into the function. So for instance, I always like to start with 0. So 0 squared is 0. And if you notice, that is a point on the graph. Then I like to do 1, and 1 squared is 1, which is also a point on the graph. And then I like to do 2, and 2 squared is 4, also on the graph, and 3, and 3 squared is 9, also on the graph. And if you notice that those same values, if I input the opposite of x, so if instead of starting with 1, I input -1, well, what's -1 squared? It's still 1. So once I get these values over here on the right, I can just mirror them across the axis of symmetry because they're reflected. So what we're going to do as we're learning to graph is it's super important that you memorize this table of values right here and to understand that this point, if it's 1 away, if this is the axis of symmetry, if it's 1 away on the right, then it's going to be 1 away on the left. If this is 2 away on the right, it's going to be 2 away on the left. 3 away on the right is going to be 3 away on the left. And this connects to our geometry when we talked about reflections. All right, so we talked about the parent graph being y equals x, but we have all these transformations that happen to the parent graph, and we end up with, as you saw when we dealt with linear regression, this equation. So y equals ax squared plus bx plus c, where a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant on the end. So we also can call the ax squared the quadratic term, the bx is the linear term, and then the c is, like we said, it's the constant. All right, so now we're going to talk about what those different values, those coefficients, do to the quadratic term, the linear term, and the constant term, and how that affects what the graph looks like. So we have our parent graph, which is something like that. Obviously, that's not perfect. But what happens when a changes? What happens when the coefficient in front of the x squared term gets bigger or smaller? So bigger would be an integer, and smaller meaning a fraction. So the larger values of a are going to make the parabola thinner, and we call that vertical stretch. You need to be familiar with that terminology. We're going to use it a lot. So when I have large values of a, so when a is a larger number, it's going to increase at a faster rate because I'm multiplying it by a larger number, so the output is going to get higher faster. So it's going to become thinner, and we call that vertical stretch. And if a is smaller, meaning I'm dividing that output because a fraction is the same as dividing, it's going to get wider, and we call that vertical compress. So that's how that a value is going to affect the outputs of the parent graph. Also, when a is positive, the graph is going to be opening up, and when a is negative, the graph opens down. So the sign that is in front of the a term, all it does is it determines the up or down. So the linear term, this is going to tell me the shift. So the b is going to shift the axis of symmetry away from the y-axis. The direction of the shift depends on the sign of the quadratic coefficient and the sign of the linear coefficient. So we're not going to do a whole lot, but just know that the b term is what moves the graph left or right in conjunction with what's happening in a. And then the c, that just tells me my y-intercept, because the y-intercept is when x is 0. So if x were 0 here, that's 0. And if x were 0 here, this is 0. And so whatever is left on the end is going to tell me what y is when x is 0, because those will cancel out. So that constant term in a quadratic is nice and easy, and it tells me the y-intercept. All right, so what I want you to do on this, because this is review of Algebra 1, I'd like you to pause the video, see if you can identify the a, the b, and the c, so the quadratic term, the linear term, and the coefficient, or the constant, and also see if you can determine what the y-intercept is. Remember, that's always written as an ordered pair. And as far as the end behavior goes for this video, just tell me if you think it's going to open up or down, and then we'll talk more about how to notate that in class tomorrow. All right, so hopefully you were able to identify the different a, b, and c values of each quadratic equation. You were able to pick out the y-intercept as an ordered pair, and you were able to identify just whether the graph is going to open up or open down. So go ahead and check your answers now. All right, so our goal of graphing a quadratic function given in standard form, we've been able to do 2 of our sub-objectives. So I can identify key features given a graph, and we're going to move on to the equation part a little bit more, but you were able to pick some things out, and to identify the y-intercept. So what I want you to do right now is I want you to pause the video, and you're going to have an interaction in your notes. So what are things you're going to need to remember? What is your understanding? What questions do you have? What picture can help you? What, just anything that you're going to want to look back at when you're studying. So do that now in your notes. All right, so this is quick review of our Module 1, being able to identify the domain and the range. And like I said, we're going to keep it in terms of interval notation just for this module, just to keep it simple. So go ahead and pause the video right now and see if you can identify the domain and the range of this quadratic function. All right, so hopefully you were able to pick out that the domain is negative infinity to positive infinity, because there is no value of x that I cannot put into the function, so all real numbers. But my range is going to go from 12, which it can be 12, so we have a bracket, all the way up to infinity. All right, so that was a quick review because we did really well with domain and range, so I can identify the domain and range. Is there anything that you're going to need to remember? Draw a picture. What is always going to be true? What are you going to need to look for? What questions do you have? Go ahead and have an interaction in your notes. All right, so in order to be able to graph quadratic functions that are in standard form, these are the things that you're going to need to be able to do. So, did I identify the y-intercept? Did I explain the end behavior? Did I identify if it has a maximum or minimum? Did I calculate the axis of symmetry? Did I identify the vertex? Did I identify the domain and range? Did I identify the zeros? And did I use the parent graph table, which is what we talked about earlier, to graph at least 2 other points and then reflect them? All right, so I'm going to go through those mastery criteria questions in order to graph this quadratic function. So I'm given y equals x squared plus 4x. So the first thing I'm going to do is I'm going to identify all the things that I can pick out just by looking at the equation. So for instance, the y-intercept. The y-intercept is the constant that's being added or subtracted on the end. And so if there is no constant, I can say that the y-intercept is 0, 0, because there is no number. Now, if there was a 4, it would be 0, 4. All right, I can also identify, just by looking at the graph, the end behavior. So the sign that is in front of the quadratic coefficient is the one that tells us the end behavior. So because there is no negative sign there, it's positive, that means it opens up. And again, later in this lesson, when we talk about things tomorrow, we're going to look at how do I describe that notation-wise, but for right now, just opens up. So because it opens up, I can tell if it's a maximum or a minimum. So when I think about opening up, we're talking about a graph that does that. So opening up means it's going forever in the positive direction, which makes this the lowest point, so it has a minimum. So for the remaining things, axis of symmetry, vertex, domain and range, zeros, and other points, I'm going to actually have to calculate using the quadratic. So those are the 3 things that I can identify just by looking at the equation. So we always want to start with the axis of symmetry. And if you remember the axis of symmetry, we use that formula, x equals the opposite of b over 2a. So in order to determine what goes into where, I need to identify what a, b, and c are. So we already said that c is 0 because there was no coefficient or constant on the end. A is 1 because the number in front of the x squared is an understood 1, and b is a positive 4. So I've identified a, b, and c. So now I'm just going to plug those into my formula. I'm going to say the opposite of b. Well, if b is 4, then the opposite of 4 is going to be negative 4 over 2 times a, which is 1. So negative 4 divided by 2 is negative 2. So I have an axis of symmetry at negative 2. So I'm going to go to my graph, and I'm just going to draw a dashed line to show that that is where the graph is going to fold in half. So it is shifted to the left 2. So x equals negative 2 for the axis of symmetry. All right, the vertex. So when I think about that parent function, I know that the minimum in this case, because it opens up, the minimum is going to be the point where the graph changes direction. So if you think about, I know it's opening up. So here it's going down, and at that lowest point or that minimum, it's going to change direction. Well, if you notice, that's happening at the axis of symmetry. So that is the place where the graph is going to be folded in half. So I already know that the x-coordinate of the vertex is going to be at -2 because the vertex has to be somewhere on my axis of symmetry in order for that pattern to continue. So that's what's something that's super important is we said the axis of symmetry happens at x equals -2. Well, the vertex is on that because that's the point where the line is being reflected, or the graph is being reflected. So I already know that my vertex, that lowest point, because it's got a minimum, is going to be where x is -2. So I can already say that the ordered pair of the vertex is -2 something. So now I have to decide what that something is. So we're talking about this function right here, where all the ordered pairs that make this true are going to be on the line somewhere. And so I'm looking for the output. What is the y value at the point where x is -2? Well, this is nice and easy. All I have to do is take my equation and plug -2 in to find out what the output is at that given input. So I just took my function, y equals whatever x is squared plus 4 times whatever x is, and we're looking specifically when x is -2, and then I just calculate. So -2 squared is 4, plus 4 times -2 is -8, and 4 minus 8 is -4. So y is -4 when x is -2. So I now know that I have a vertex at 4, or -2, -4. All right? Okay, so now that I know the minimum, I can technically state the domain and the range. So you can go ahead and do that if you'd like, because I know it's going to open up. But I'd like to come back to that one when I see the whole picture. The zeros, we don't know the x-intercepts yet, so we're going to skip that. So one thing we can do right now is we can graph the y-intercepts. So it is at 0, 0. And I know that the axis of symmetry means anything on the right-hand side is going to mirror over to the left-hand side. So if this is 2 away from the axis of symmetry on the right, then its mirrored point is also going to be 2 away from the axis of symmetry on the left. So I can already see the shape of that. Now I will tell you, in order to be an acceptable graph for my class, you need at least 5 points. So right now we have 3. So the cool thing is if you can find the y-intercept and you can find the vertex, you've already got 3 of the 5 that you need. So we just need 1 more. So if you recall when we talked about that parent graph table, this is going to be super important. And these are values that I want you to memorize. I want you to memorize 1, 2, and 3. So 1 squared is 1, 2 squared is 4, and 3 squared is 9. So what this is going to do is this is going to allow us to use the vertex and apply these ideas as movements in order to graph the function a lot quicker. Because technically, I could go over and I could say, okay, I know the value when x is -2, and I know the value when x is 0. What's the value when x is -1? And I could plug -1 into the function and calculate it. But this is going to save you a lot of time. So when x is 1, so when I have a movement of 1 to the left or right, my y movement is going to go up 1. When I have a movement of 2 left or right, the y value is going to go up 4. When I have a movement of 3 left or right, the y value is going to go up 9. So let's look at this in context of this problem. Since my A term, which we talked about, the A term tells if it opens up or down, but it also tells if it has that vertical stretch or shrink. So the A term is a 1. So we would essentially say that we're going to multiply these values by 1, which if I multiply them by 1, they're going to stay the same. So from this point of -2, -4, if I shift over 1, so that's my x, I'm going to go up 1. So if I go from the vertex over 1, I'm going to go up 1 because I'm following that quadratic pattern. And if I shift over 2, I'm going to go up 4. So if I shift over 2, 1, 2, 3, 4, which we already knew because it happened to be my y-intercept, and if I shift over 3, I can go up 9. So that is a continued pattern. However, I've already got a point here, so now I'm going to reflect it, and now I have my 5 points that give me my quadratic. And so I have graphed that quadratic. So I now have everything that I can answer these remaining questions. So the domain and range is -infinity to infinity and -4 with a bracket, because that is the value that is acceptable all the way to infinity. I have zeros, or my x-intercepts are when x equals -4 and when x equals 0, and then the other points are already on the graph. I realize that's a lot of information that I just threw at you, but the more we do this, the quicker it's going to get. Alright, so what I'd like you to do is pause the video and see if you can answer these first 3 based off of just looking at the equation. So hopefully you were able to identify that the y-intercept is going to be 0, -21, because if x is 0, which is what it is at the y-axis, then those will cancel, and that leaves me with y being -21 when x is 0. I see that the a term is negative, so it's going to open down, which if it's opening down, that would make my vertex the maximum. Alright, so now I'd like you to pause the video and see if you can calculate the axis of symmetry and the vertex. Alright, so hopefully you were able to use the opposite of b over 2a formula to determine that the axis of symmetry is at x equals 3. So I drew my dashed line down there showing where that axis of symmetry is. The vertex is on the axis of symmetry, so it has to have an x value of 3. So I went to my function and I plugged 3 in, and when I calculated it out, I got -3. So I know that my vertex is at 3, -3. So next, I could go and graph my y-intercept, which was 0, -21, but that is way down here. I can't graph that. So the y-intercept really isn't going to help us in this problem. So I'm going to go to that table. 1 squared is 1, 2 squared is 4, 3 squared is 9. Now, that's my normal parent graph function, but another transformation that's happened is not only are we taking the parent graph and shifting it left or right, but we're also giving it a vertical stretch. So we're multiplying it by -2, meaning instead of going over 1 and up 1, like this says, so a right or left movement of 1 and a vertical movement of 1, a right or left movement of 2 and a vertical movement of 4, we're now doing that times a -2. Really what that's going to produce is a right or left movement of 1, and then instead of going up 1, I'm doing up 1 but times -2, so really I'm going down 2. And then instead of going up or down 4, instead of going up 4, I'm really going down -8, because I'm essentially taking what was the parent graph and multiplying it by -2. So 1 times -2 is -2, 4 times -2 is -8, 9 times -2 is going to be -18. So now these are the movements that I'm going to graph. So I'm still going to go over 1 from my vertex, but that -2 says go down 2. And then I can reflect it. And then I'm going to go over 2 from my vertex. Remember, these are always movements from the vertex. So from the vertex, I'm going to go over 2, and I'm going to go down 8. So over 2, it's going to be like right there. And then that's going to reflect over here. So you can see